Hey guys, this is R.8. It is the last lecture of our review unit. So that means we'll have the exam and then we will start unit 1 after this. We are doing radicals and rational expressions today. All right, so first of all, we have the cubed root of 64. What this is asking is what number can I raise to the third power and get 64? The cubed root of 64, okay? So in fact, the cubed root of 64 is 4 because 4 times 4 times 4 times 4 is 64. On your calculator, you can hit math. Oh, you could put the number 4 in, hit math, and then down to number 5, which has the x. 60. Oh, sorry, we're just doing 3. The answer is 4. All right. So you can put a 3 and go down to 5, and then say 64. The cubed root of 64 is 4. So B, the cubed root of -8, you could do that same thing. The cubed root of -8 is -2 because -2 times -2 times -2 gives me a -8. Now remember, one of our rules is you cannot take the square root of a negative number, but you can take the cubed root. So if this number is even, you cannot put a negative number under here because no even number of terms will equal a negative number. But an odd amount of negative numbers multiplied together will always give you a negative. So that is okay to put the negative here as long as this number is odd. If there's no number here, remember it just means 2. So just a square root symbol is the same as saying the square root of 2. We say it's an understood 2, an understood square root. All right, for C, we have the 4th root of 1 over 81. I like to change these to the 4th root of 1 over the 4th root of 81. What multiplied by itself 4 times will give us 1? It's 1, right? 1 times 1 times 1 times 1 gives me 1. So the 4th root of 1 is 1. And then what can I multiply times itself 4 times? 1, 2, 3, 4, and get 81. It's not 2. It's 3. Good. Or I can just say the 4th root 4 of 81 is 3. So this answer is 1/3. Good. Now we have the 6th root of -4 to the 6th. This is an even number, right? And we said we can't have a negative term with an even root, but first we're going to multiply it by itself 6 times. So -4 to the 6th power. Is a positive number. So that number we can put under the root. 4096. And we get 4. So if these two are the same, you're going to take this term, but it will always be positive, right? That answer is 4 because the 6th root of 4096 is 4. And we got this number by multiplying 4 times itself 6 times, -4 times itself 6 times. Good. So what we see here is that the radical is related to the exponent, right? They are inverse operations of each other. So if I say the square root of 25 is 5, it's because 5 times 5 is 25, right? Or 5, sorry, I should say 5 squared is 25. So you see how these are inverses? All right. Let's go to the next page. Properties of radicals. So this is what we saw before, right? We said the 6th root of -4 to the 6th is 4, right? If it's an even number, you have to take the absolute value. It will always be positive. If it's an odd number, it could be positive or negative. So let's look at the third root. The third root of -4 to the third. We get a negative number. If we take the fourth root, which is even, right? The fourth root of -4 to the fourth, we will get a positive number. So that's what this means. The absolute value means it will always be positive, right? But if they're odd, like the 3, it could be positive or negative. It's just whatever is actually there. Here we took that and gave the absolute value of it as the answer. Okay. Our other properties are that the root of a times b is the same as the root of a times the root of b. The root of a divided by b is the same as the root of a divided by the root of b. B can't be 0 because we can't divide by 0. And then the root of a to the power of m, I can change to, and I can either do this part first because it's the exponent, or I can put this into parentheses and do this part first and then raise it to the m. Okay. So here we have the square root of 50. And what we're going to be doing with this is making factor trees. So the factor tree for 50. 50 is, I'll say 25 and 2, right? 25 times 2 is 50. The next layer of my factor tree until I get to my prime factorization, 25 is 5 times 5, right? There are no factors of 2, so I just bring it down. 5 times 2 is still 50. And this is my prime factorization because I can't factor 5 and I can't factor 2. This is an understood 2, right? So that means I'm looking for pairs. 5 times 5 means that if I put it under here, 5 times 5, it comes out as 1, 5, right? It's the same as saying 5 squared. So when I'm making my factor tree, I'm looking for pairs because this is a 2. So I have 2 5s. So I can in fact change this. The 5s come out. So it was 50. It was the square root of 50, right? Then it became the square root of 5 times 2 based on my factor tree. And then I can take the 2 5s out and put them in front as 1 5, right? 5 times 5, the square root of 5 times 5 is 5. So now I have 5 square root 2 as my final answer. Good. All right, let's go on to B. B is the third root or the cubed root of 54. So again, I'm going to do the same thing. How can I factor 54? 54 is actually 9 times 6, right? 9, the prime factorization of 9 is 3 times 3. 6 can be factored into 3 and 2. So the cubed root of 54 is the same as the cubed root of 3 times 3 times 3 times 2. 3 times 3 times 3 times 2 will give me my original term. Every row of my factor tree, if I multiply it, will give me that number. So because this is now a 3 up here, I need 3 terms. Okay. The square root of 2 3s is 3, but the cubed root, it has to be 3 3s. So you want the quantity of the term to equal that before you can take it out. So that becomes 3, don't forget the cube sign, cube root, and then the 2 stays inside. So the answer of the cube root of 54 is 3 cube root 2. So that's the simplest form. And you can just put it into your calculator. 3 times the cube root of 2 is that term. And then the cubed root of 54 is that same term. So that's how you would check your answer. All right, example C. The cubed root of negative 24 x to the 5th. So if it's an odd cube, or sorry, if it's an odd root, that means I can take a negative term and my answer will be negative, right? Because it means I'm multiplying 3 different numbers or 3 different terms because we have numbers and the x. So it would be negative times a negative times a negative. So for that reason, I'm just going to take the negative sign out. So now I'm going to say it's negative cubed root 24 x to the 5th. Okay. Now 24 becomes what? What's a good way to do 24? 6 and 4? 6 becomes 3 and 2. 4 becomes 2 and 2, right? 3 times 2 times 2 times 2 will give me 24. X to the 5th just means I have 5 x's behind it, right? So I'm going to rewrite this as negative cubed root 3 times 2 times 2 times 2 times 5 x's. Now, what can I take out that has a grouping of 3? I can take out 3 2's, and I can take out 3 of, we're at 4, 3 of the 5 x's. 1, 2, 3, 4, 5. Good. So that becomes 2. Ooh, sorry, negative 2. Can't forget that negative sign that I took out. Negative 2 x. Everything else stays inside. Cubed root of x. I don't need to write 2 x's. I can just write x squared. Negative 2x times the cubed root of x squared. Good. All right, last one. Yeah, I guess I have to. Last one is D. So I have the 4th root, and remember I can change it to an individual, right? So I'm going to split it into the 4th root of the top divided by the 4th root of the bottom. The 4th root of 81 x to the 6th. So let's do 81. 81 I think of as 9 times 9, right? Or you know what you can do? You can just say, is this going to give me a whole number? It is. So we could factor it and say it's 9 times 9. 9 is 3 times 3. 9 is 3 times 3. And then we have 4 3s. Or you can put it in your calculator. And then we have 6 x's, right? So that becomes the 4th root of 3 and 6 x's. So there are 4 3's. I need 4. And there are 4 x's. Oh, I circled 5. So my answer on top is 3 comes out and 1 x comes out, and I'm left with the 4th root of 6 minus those 4 I took out is squared. Good. And then on the bottom, we have 256. Let's just see. The 4th root of 256 is 4. Good. 3x times the 4th root of x squared over 4. That's my final answer for D. Okay. All right. Now, just like we were combining like terms, we can combine like radicals. We can collect radicals that are alike. So first of all, you have to make sure they have the same index. These both have an index of 2. That means that there's a 2 right here, right? And these are called the radicands. So here I have a radicand of 5, and here I have a radicand of 20. Good. Not exactly the same, so I can't combine them, but I can multiply it, or I can simplify the 20. The 20 can become a 5 and a 4, right? And then the 5 is a prime, but the 4 can become a 2 and a 2. And I'm looking for pairs because that's 2. So I have 5 times 2 times 2. So what that turns into is -4 times the square root of 5 times 2 times 2. The 2's come out. So now I have -4 times 2 times the square root of 5, which becomes -8 square root of 5. And then I'm going to bring this guy down from way up here. Now we have like terms plus the square root of 5. So now we have the same index of 2 and we have the same radicand of 5. So we can just combine them. So that final answer is -8 plus 1 is -7 square root 5. Okay. All right. Here we have an index of 3 and different radicands, right? So let's start with 3 times the cubed root of 8x. Come down here. First term in B is 3 times the cubed root of 8x. So I'm going to take 8 and I'm going to say 8 becomes 4 and 2. 4 becomes 2 and 2. So the cubed root of 8 is actually 2, right? And then I have 1x. So that becomes 3 times the cubed root 2 times 2 times 2 times x. I can take out anything that's a group of 3. So now I have 3 times 2. And the x is the only thing left in there. So that, oops, I forgot that 3. Never change that to a 2. If you leave it blank, it becomes a 2. 3 times 2 is 6. So now I have 6 times the cubed root of x for my first term. 6 cubed root x. Good. The next piece of B is 5 cubed root -x. All I can do here is take out the negative sign. Remember, if it's a -x and this is odd, it's possible, and the answer will be negative. So now I'm just going to say it's -5 cubed root x. So that becomes -5 cubed root x. But I see that we have now the same radicand and the same root. So that's good. And then my last term is the cubed root of 64 x to the 4. 64 can become what? 64 can become 8 and 8. And I need 3. 2 and 4. 2 and 4, right? And then 4 becomes 2 and 2. And again, you're welcome. I apologize. You're welcome to just put this into your calculator without the x and see what you get. So here we have, if I didn't make that too confusing, this 2, the 4 becomes 2 2s, this 2 comes down, the 4 becomes 2 2s. So now I have 1, 2, 3, 4, 5, 6 2s to equal 64. Two times 2 times 2 times 2 times 2 times 2, and then 4 x's. Good. So now I can take out, this is 1 2, this is 2 2s, and 1 x. So that becomes 2 times 2 times x cubed root x, which is 4x cubed root x. And if you had just put 64 into your calculator, you would have gotten it much faster than me. So there's many different ways to make a factor tree. You didn't have to start with 8 and 8. I could have started with a 4, but you'll end up with the same answer, even if you have to go back and multiply. 2 times 2 is 4. Yeah. All right, so this becomes +4 cubed root x. So we have the same, as we said, we have the same radicand of x. And we have the same root of 3. So now I can just combine them. 6 minus 5 is 1, plus 4 is 5. Good? Oh, no, sorry. Because this is 4, I forgot, I did not bring up the x. I apologize. This 4 has an x, remember? I'm sure you remember. I'm sure you copied it correctly. So that's actually 4x. So I cannot combine all of them. I can combine the 6 minus 5 is just 1, right? And then I leave the 4x because I can't combine a 4x with a 6 or a 5 because of that x that made it out. So there's my final answer for B. Here's my final answer for A. Okay, now we're going to practice rationalizing the denominator. So denominator is the bottom of the fraction. We can never leave a fraction with a radical in the denominator. So we're going to rewrite the fraction to rid the denominator of the radical, or to get make sure there's no radical or no root in the denominator. That's all we're doing. Okay, so here I have 2 over the square root of 3. I can't have this be square root of 3. What do I multiply square root of 3 by to get rid of square root of 3? Here I have the square root of 3. It's not a whole number. Square root of 3 times what? What if I did it times itself? Yes, that gets rid. So if I multiply it by itself, it gets rid of the radical, as long as the radical is 2. If it was 3, I would have to do it 3 times, right? Oh my goodness, my fingers. So however many times, whatever the root is, that's how many times you need to multiply it by itself to cancel out the root. So I'm going to multiply the bottom by square root of 3. If I multiply the top and the bottom of the fraction by the same term, I'm multiplying it by 1, thus not changing the value, just changing how it looks, right? We're just rewriting it without changing the value. 2 times the square root of 3, I just write as 2 square root of 3 because I don't care. It's okay if the numerator has a radical. Square root of 3 times square root of 3, we just saw, is just the square root of 3 squared, which we know becomes 3. So now we have 2 square root 3 over 3, and we are done. Good. Here, 3 over 5 square root of 2. I want to get rid of the square root of 2 by making the square root of 2 a perfect square. Perfect square, just like here, means we multiply it by itself. I don't need to multiply it by 5 square root of 2 because the 5 is fine. It's just the square root of 2 I want to get rid of. So that becomes 3 square root of 2 on the top, and then 5 times the square root of 2 times the square root of 2 is 2, right? The square root of 2 squared, which is 2. So that finally is 3 square root of 2 over 10. Is that okay? Does that make sense? We made that square root of 2 into a perfect square. The denominator does not have a radical in either example now. Okay, so how do we translate between exponents and the radical, right? A to the power of 1 over n will always equal n root of a. So a to the power of m over n means that m becomes the exponent, n becomes the root. Okay, And you can keep that radical, or sorry, you can keep that exponent under the radical, or you can move it out of the radical. So to write this again, we would have here's my x, and here's my other x. So here I have x to the exponent over the root. That's my fraction. Good. So I can change it to x. This is always the root. And then my exponent stays up here where all exponents are. Is that okay? So you take that first term, it's a 1, you don't even need to write it. You take that first term and leave it with the base, but the bottom of that fraction then becomes the number you put right here, okay? All right, so let's rewrite some of these using this, okay? And I'll even color it. So maybe this one is blue. I'm afraid you won't be able to read it if I color it too thoroughly. Okay, so we're taking that top number, we're leaving it with the base, we're taking that bottom number and we're putting it as the root of the radical. All right, let's start. So 9 is our base. The first number is going to be the exponent, so 9 to the first power. The second number, the denominator, is going to be our root. So the square root of 9 to the first power, which just looks like this symbol, right? 9 to the first is just 9, so that's actually 3. Because another way to write that is, right, that's the same. The 2 is understood, the 1 is understood. Now I have -8. Oops. Let's just write the radical right now. We have -8, and I'm going to preserve the parentheses because it's a negative. The first term goes with the exponent, remains an exponent. The third term goes here. So now I can just put it into my calculator. The third root of, the third root of -8 is -2. And you can see I kind of ignored that 1 because -8 to the first power just means -8 one time, right? 12 to the 1/2 becomes, the first term is the exponent, 12 to the first. The second term is the root. So the square root of 12. There is no perfect square of 12, or 12 is not a perfect square, right? But we have been making factor trees, so I'm just going to check if I can factor it at all. 12 becomes 3 and 4. 4 becomes 2 and 2, right? So I can actually change the square root of 12 to, where should I write this? Right up here. All right, the square root of 12 can become the square root of 3 times 2 times 2, which can become, the 2's come out, right? 2 square root 3. And you can check that in your calculator. So for this answer, I'm going to say the final answer is 2 times the square root of 3. We're probably going to be doing the same thing with 54, right? So I have my radical, I have 54. The 1 stays with the 54, so 54 to the first power. And then the third root of 54. 54 can become 9 and 6. 9 becomes 3 and 3. 6 becomes 3 and 2, right? So that becomes the third root of 3 times 3 times 3 times 2. I'm just going to go straight down, which becomes the third root of, the 3's get to come out in front. 3 times the third root of 2. So 54 becomes 3 third root of 2. Let me, so our first answer was 3, second answer was -2. This one is 2 square root 3, and now we have 3 cubed root of 2. Okay, let's keep going. 9 to the power of 3 over 2. Again, maybe I'll put it on a note card. Oh, I'll put it on the same note card as our other notes. So I have this, and now I have x exponent root becomes root exponent. Good. All right, so now we have that top number stays with the 9, and the bottom term becomes the root. All right, so we know that the square root is the same as just saying this, right? And that we can either say 9 to the 3rd or 9 cubed, or we can say the square root of 9 cubed. Good. The square root of 9 we know is 3, right? 3 cubed is 27. Or we can say the square root of 9 cubed. Either way, you get 27. So here our answer is 27. All right. Next example, I'll change colors so that we don't get. We have negative 27 in parentheses 4 over 3. So I know my 4 stays with my negative 27. Negative 27 to the 4. And that this is a cubed root. Negative 27 to the 4th. And then the cubed root of that is 81, or the cubed root of negative 27 to the 4th power. Either way, we get 81. And feel free to just put this whole thing into your calculator. So that's 81. Now we have 32 to the negative 3/5. The root is the 5, so I have 32 to the 5th. And then I'm going to take the cubed root of that. Cubed root of 32 to the 5th is that. Oh, sorry. Negative. All right. So maybe I did that wrong. The root negative 3/5. Sorry, I wrote that wrong. There are already so many mistakes. So the 5 should go here, the 3 should go there, and it needs to be a negative, right? We're going to put the negative with the exponent because we don't really do negative roots, we do negative exponents. So now, instead of the mistake I made, we will have a positive 5 here, a negative 3 here, and we'll keep that base the same. Good? Okay, when we have a negative exponent, remember what we do is we move it to the bottom of the fraction, right? So what I think would be easier now is to do the 5th root of this number before I change it to the bottom to the denominator of a fraction. So I'm going to say this now becomes the 5th root of 32 all to the power of negative 3. So the 5th root of 32, if I put it in my calculator correctly this time, the 5th root of 32 is 2. So now I just have 2 to the negative 3. 2 to the negative 3 gives me a decimal because remember what I need to do is move it to the bottom, move it across a fraction bar to get rid of that negative sign. We never leave a negative exponent. So it's actually 1/8. Good. So because that was a -3, we moved it to the bottom. 2 to the third is 8, so we get 1/8 as our answer. And then the last one is 16 to the 12/8. So those are big numbers. I also know that they're both even and they're both divisible by 4, so I can just divide it by 4, right? 12, let's look at this. 12 divided by 8 can be changed to 3/2, because if I divide both of those by 4, 12 divided by 4 is 3, 8 divided by 4 is 2. Good. Now let's see if I get this time. The second number is the root, the first number is the exponent. So I'm going to say 16 to the third power squared. Good. So I know that this is a perfect square, so I'm going to say the square root of 16 cubed. The square root of 16 is 4, right? Because 4 times 4 is 16. 4 cubed is 64. Good. All right. Last page. So now we're going to simplify each expression and express your answers so that only positive exponents are written, okay? Assume that the variables are positive. So first we have x times y to the 1/2 power times x times y to the -3, but the x and the second x and the second y are both taken to the power of 2/3. So I'm just going to begin by rewriting this, okay? I'm going to rewrite it and I'm going to distribute that 2/3. So what I have is x times y to the 1/2 times x to the 2/3 times y to the -3 times 2/3. Okay. Oh, sorry. Yeah, that's correct. Because if I'm raising the -3 to the power of 2/3 by the rule, according to the rule of exponents, I'm multiplying them, right? So that -3, if I'm going to multiply it with another fraction, becomes a -3/1, right? So now I can rewrite that as x to the first times y to the 1/2 times x to the 2/3 times y to the -6/3, right? And -6/3 just becomes -2, right? So I'm going to rewrite this again as x times x to the 2/3, good, times y to the 1/2 times y to the -2, okay? So when I'm multiplying things with the same base, I'm just adding those exponents. So this has an exponent understood 1, right? So I have x1 plus 2/3 times y 1/2 plus -2. I want to change these to fractions, so I'm just going to put the -2/1 and the 1/1. Good. Now I need to add fractions. So we might do that up here. So now I have, no, I'll just do it here. I have 1/1 plus 2/3. I want them to have the same terms, like terms in the common denominators. So I'm going to multiply this side, this whole fraction, by 3. Now I'll get 3/3 plus 2/3, which is 5/3. Good. So my x is now 5/3. Now my y was 1/2 minus 2/1, right? And same problem, I need common denominator. So I'm going to multiply this by 2, multiply this by 2. rewrite it as 1/2 minus 4/2. 1 minus 4 is negative 3/2, right? So these two became this. These two became this. I'm gonna write it again. X to the power of 5/3 times y to the negative 3/2. Good. Remember, it said express your answer in only positive exponents. In order to make this negative exponent a positive, I move the y down. Now I have x to the 5/3 divided by y to the 3/2. That's now a positive. We moved it across the fraction bar. That is my final answer. Okay. All right, let me get another piece of paper. Our next example is Our next example is 3x to the 1/2 over y to the 3/2 all to the power of negative 2. Okay, so I need to distribute that negative 2. So now it becomes 3 to the negative 2 times x times 1/2, x to the power of negative 2 of 1/2 times negative 2. Again, that's not a fraction, so I'm just going to make it one. Good. Over y to the power of 3/2 times negative 2, turn it into a fraction. Now I'm going to move things that are negatives. No, I should multiply first. So I'll just leave that as 3 to the negative 2 times x. If you're multiplying fractions, you just go straight across. So here I have 1 times negative 2, so that's negative 2. 2 times 1 is 2. Here I have y. 3 times negative 2 is a negative 6. 2 times a 1 is a 2. Simplify that as 3 to the negative 2, x to the negative 1, right? Because 2 divided by 2 is 1, over y to the negative 2, because negative 3, because 6 divided by 2 is 3. Okay? Now it says we cannot leave any negative exponents, so this will become, what I need to do is I need to move the 3 down. I think I'm moving everything, right? The x needs to go down and that y needs to go up. Everything's going to get changed around because every single term is negative. So now on the top, I have y to the 3rd, and on the bottom, I have 3 squared x, right? Because a negative 1 just becomes a 1. It means 1x. 3 squared is 9, so all I would change is I would change that to a 9x, and then I'm done. Y cubed over 9x. All right, our last example. We have 8x squared y to the 1/2 to the 1/3 over x to the 1/2 y, the power of 1/3. Now I'm going to distribute that 1/3. So now I have 8 to the power of 1/3 x 2 times 1/3, change that 2 to a 2 over 1 so I can multiply it. Y 1/2 times 1/3, because if we're raising an exponent to an exponent, we multiply them. X 1/2 times 1/3 times y to the 1/3. Simplify that. 8 to the 1/3 times x, 2 times 1 is 2, 1 times 3 is 3, to the 2/3, y, 1 times 1 is 1, 2 times 3 is 5 to the 1/5, x to the 1/5, oh, sorry, I'm adding 1/6, x to the 1/6, y to the 1/3. Good. All right, so now I have some common terms between the top and the bottom. When I'm dividing exponents, the rule of exponents is that I subtract, right? So for my x's, I can see that it is x to the 2/3 over x to the 1/6, right? That's going to become x to the 2/3 minus 1/6. Once again, look at the fractions. 2/3 minus 1/6. I need common denominators, so I'm going to multiply this side by 2. 2 times 2 is 4. 3 times 2 is that 6 we needed, minus 1/6 becomes 3/6 or 1/2, right? So now that x is the 1/2. Let's do the y's. We have y to the 1/6 over y to the 1/3, which becomes y 1/6 minus 1/3. So now for our fraction, we have 1/6 minus 1/3. We need common denominators, so I'm going to multiply this side by 2 to get 6 in the denominator. Now I have 1/6 minus 2/6, which is a negative 1/6. So that becomes y to the negative 1/6. Okay, so now I have 8 to the 1/3, x to the 1/2, y to the negative 1/6. The only thing I need to change now is that this y can't be negative. So I'm going to change it to 8 to the 1/3, x to the 1/2 over y to the 1/6. Good. 8 to the 1/3 becomes 8. The 1 stays here, the 3 goes here, according to this, right? The bottom number of that fraction is the root. The cubed root of 8 The cubed root of 8 is 2. So now I have 2x to the 1/2, y to the 1/6. And that is our final answer. All right. Thank you guys, and I will see you next time.